Welcome back. Today we're going to go over the area of regular polygons, the most difficult type of area there is. So, we're going to today be able to identify the parts of a polygon and then find the area of a regular polygon. So, let's get started with a picture of a polygon. In case you guys forgot, what a polygon is a shape that's closed. All the sides are straight, all right, and no pieces overlap, all right. So it's a closed figure with all straight sides that never overlap. Right, pretty easy one. We're going to be dealing with regular polygons, which are always convex, okay, and all the sides and angles are always equal. So that's the ones that we're going to find. Otherwise, you have to use a regular rule. So, center of a polygon, right there. Same distance from each vertex. Pretty easy. So that means if I wanted to go to each one of these vertices, the center would be the same distance. The radius is that distance. It's the distance from the center to the vertice, center to vertice, center to vertice. So it's these red pieces right here. All right. The apothem of a polygon, probably a word you never heard of before. That's from the center to here. Now, what does this piece look like? That looks like the midpoint of each side. So that means that these two pieces are equal. And this pretty much bisects each segment. So you have one for each side as well. All right. It forms a right angle with that side. This is very important. So it's going to form a right angle here. And it also, like I said before, is the perpendicular bisector. So pretty much what this does is the radius and the apothem make a right triangle here. You have two right triangles for each side. So this 5-sided hexagon would have 10 right triangles that are all congruent inside of it. That's how we're going to find our area. Central angle of the regular polygon. So the central angle is the angle formed by two adjacent radii. We're not really going to be using that too much, but this is the angle right here. All right, the way you would find the central angle is you take the number of sides and do 360 divided by that. All right. If you want to use trig stuff later on, we can use that for trig functions. But we're not going to even get into that because this is just a bonus quick episode. Lesson 7. So, first thing, we're going to find the angle measurement of a regular polygon. So I'm going to start you off really difficult and then get easier. Right? Isn't that nice to do? So, ABCDEF is a regular hexagon. Oh, wait. Did I say the 5-sided figure was a hexagon? I meant pentagon. Whoa. Losing it there. You'd think a geometry teacher would know that. Inscribed and circle G. Find each angle. So now we're just going to find the central angle. We're going to start easy. So there's 1, 2, 3, 4, 5, 6 sides in a hexagon. And we know that E, G, F, the two radii right here, and G in the middle forms the central angle. All right, so we're going to find a bunch of angles. So how do we find that? Well, as I said before, 360 by the number of sides. How many sides does a hexagon have? 6. So 360 divided by 6 gives you 60. And the reason is that, look at 60, 60, 60, 60, 60, 60. All adds up to 360. All right, so measure of EGH. EGH. All right, so what's half? Oh, there to give you the answer. So this angle right here, EGH. So I'm going to pull out this piece and put it down here. So EGH, GH is actually a perpendicular bisector because this is the apothem. It's perpendicular to the side and it's cuts it in half. And this is an isosceles triangle right here. So GH bisects that angle right there. So watch what happens. This angle is 60, right? Good so far? What happens when I cut it in half? Half of 60 is 30. So this angle cut in half is 30. Got my blue sides. I cut it in half. You got a 30 and a 30 because these two pieces are equal. Right? So they're each 30, 30. Adds up to 60. 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30. All 30s. Make sense? The sum of the measures of HEG is 180. So, what do we find here? HEG. HEG. So now we're finding this angle. So we got 90. we got 30 something, and this is another little triangle here, so it adds up to 80. So 30 in x plus 90. 90 plus 30 plus HEG is 180. 120 plus HEG is 180. 60 is HEG. So in this case, HEG is 60. So if you wanted to, which you never really need to do, you could find all the angles inside a hexagon. Now, did you need the circle? No, but the circle helps you guys realize about the 360 thing, right? Now, we're going to go to the important part, the area. Area of an n-gon. N-gon is just a polygon with an n number of sides, okay? And can be anything that is 3 and up, as long as it is not a decimal. So, the area of an n-gon, in this case, this would be a 6-gon or a hexagon, with side lengths S is, do you remember what the orange was? Half the product of the blank A. What do you think A stands for? We used that word before. Apothem and the blank P. What P word do you know that deals with the distance around a figure? Perimeter. So, P equals N. What's N? Number of sides. Times what? S. And what do you think S is? So the distance around equals the number of sides times S, which is the side length. Okay, so you multiply the number of sides times the side length. Now the area is half the product of the apothem and the perimeter, 1/2 AP. And that's it. Easy? Let's see. Problem number 2. Hardest part is distinguishing between the apothem and the radius. So, what is the perimeter of problem number 2? Hexagon, so it has 6 sides, right? So the number of sides times the side length. What's the side length here? Yell out your answers. 16. Good. So it's 6 times 16, which is 96. Which one of these is your apothem? The apothem goes from the central angle to the midpoint of a side. So, does 15 go to the midpoint of a side? I think so. Does 17? No, 17 goes to the vertices, so your apothem is 15. Area equals 1/2 AP. Half of apothem, which is 15. Perimeter, which is 96. Half of 15 times 96, 720. And that's all there is to it. It's a little difficult, but not terrible. Good. Let's move on to the next one. Find the area. Ooh. There you go. What are you going to do? Find the area of this figure right here. This has nothing to do with polygons, by the way. It's just using up everything that we've done so far. All right, let's see if you got it. You have to break these into 1, 2, 3, 4 different figures. First figure is right there. That is a trapezoid. It's only using things you know. Height is 9, 17, and 21 are your bases. And you got half of 9 times 38 because you add your bases together and you get 171. We do not need to use the 10. All right, so we're good so far? Found the first part. Now we got to use this guy. What is that? It's a rhombus. Now 8 is the distance from here to here and 6 is the distance from there to there. So those are not the diagonals. Your diagonals are twice each of those numbers. So diagonal 1 is 2 times 6, which is 12. Diagonal 2 is 2 times 8, which is 16. The area is half of 12 times 16, which is 96. And you go, why can't I just multiply these two together because I'm taking half of them? You're not taking half of them. You're taking half of 2 times each of them. All right? So you'd be, your answer, if you just multiply these together, would be 48, which is only half this answer. So find the actual diagonals first, and then take half of that. All right? What's that figure? I see a right triangle. Now look at, this is 10, so that means all these are 10. So that means this side is 10. And 1/2 of base times height, 7 times 10 is 35. And then you got this one. Well, we know this is 10, right? But in order to find this side right here, A squared plus B squared equals C squared, right? Pythagorean theorem. 7 squared plus 10 squared is C squared. 149, 100 plus 49. Square root of that is 12.2. So now you got length times width, 12.2 times, this is 10, that's 10. 12.2 times 10 is 122. Whoop, 12.2. There should be a dot right there. And what do you do with all these areas? You add them all together. 171 plus 96 plus 35 plus 122, and your total area is 424. If you got that, awesome. You pretty much picked up every single thing we've been doing so far in this lesson. Oh, that's my pencil. If not, work on it. All right, let's go back to perimeter. Let's go back to polygon area. So, in this case, area equals 1/2 apothem times perimeter, right? What's your apothem? Right there. The distance from the central angle to the midpoint of the side. That's your radius. You don't really need your radius. And your P equals perimeter. And your perimeter are the side, number of sides, times the side length. Let's go number 4. I'm going to pop over here. Get out of your way. All right, so perimeter equals, how many sides do you have? Once again, you have 6 sides. Each side length is 8, so that's 48. Your apothem is the only thing given, is 7. So half of apothem times perimeter is your formula. Half of 7 times 48. 24 times 7, which is 168. All right. So the next two, 5 and 6. All right. That's your apothem, that's your sideline. Number of sides you have here is 12. And I'm starting you off easy. I'm going to get more difficult. Don't worry if you're think this is too simple. 12 times 2 is 24. The perimeter of this 12-sided figure, or this dodecagon, is 24. Your apothem is 3. 1/2 of 3 times 24 equals 36. Problem number 6. Uh-oh. What is our perimeter? Well, 8, 3 sides. So the perimeter of this threegon, otherwise known as a triangle, is 24. Your apothem here is, which one of these? 3. It's also always the smaller one. The radius is always larger than the apothem because it goes to the outside. 1/2 of 3 times 24 is 36. Got it? You got a couple more of these to do. All right, perimeter is a 5-sided figure, is a pentagon. 5 times 12 is 60. The apothem is 6 because it goes to the central point. Whoa, I should say 6. All right, it's just the 6 upside down. All right, so 1/2 of 6 times 60 is 180. Funny how I got the right answer, but I got it wrong. All right, right over here. Perimeter, that is a 8-sided figure, I believe, which is an octagon. 8 times 21 is 168. The apothem is 26 because it goes to the midpoint. That's 28. 1/2, 26 times 168, 2,184. Now, the reason I'm starting you off easy is a lot of people confuse the radius and the apothem, and it's just good to do these problems so you know what the apothem is over and over. All right, you good? All right, let's do, crank it up a little bit. Find the area of a regular polygon. Now, this is when you would use the radius. So, first thing, a wooden coaster is a regular octagon. So, a coaster is something you put, like I would take my coffee, I put it on the coaster so I don't get a ring. I don't have any coasters. Is a regular octagon with 3 centimeter sides and a radius of about 3.92 centimeters. What is the area of the coaster? Notice you're given radius and not apothem. So the first thing is we do the first step as normal. We find the perimeter. So it's an octagon. Octagon has 8 sides. So the perimeter is 8 times each side length is 3. 8 times 3 is 24 centimeters. So we got our perimeter. Now our formula is 1/2 apothem times perimeter, but we don't have the apothem. We have the radius here is 3.92, and we're looking for the apothem. So how do you think we go about finding the radius? If you could look over at step 2, it might give you some hints. All right, so in case you didn't know, to find the apothem using the radius, half the side length and the Pythagorean theorem. Now here's what you're going to do. This right here is 3, because all these sides are 3, right? This is our right triangle that we're going to get. So if this is 3, the part of the right triangle would be half of 3. Okay, so if you look down here, PQ is 3, so SQ, the part we want, is half of 3, which is 1.5. Our radius is 3.92. This is 1.5, and our apothem is unknown. So we use the 3, which is our side length, to take half of it to give ourselves a little teeny triangle inside the triangle. So a squared plus b squared is c squared. Now our radius is our hypotenuse. So 1.5 squared plus, we don't know what b is, so we'll just call it x or a because it's our apothem. The reason I don't call it a again is I don't want to confuse you guys with the letters. C is 3.92 squared. All right? You square and you square. All right? You subtract 2.25 from both sides, and you get x squared is that, and then you take the square root. So x is 3.62. So rs, which is x, which is our apothem, is 3.62. So now we used our radius to find our apothem, and we already had a perimeter we could solve. 1/2 of 3.62 times 24, and it gives us an area of about 43.44. So the coaster is about 43 4400 square centimeters. All right? So you used your radius to find your apothem, and then use your apothem to find your area. Like a game. All right? Let's do a couple of these. And then we'll be good. Now I put the right triangles up here just to guide you guys, okay? So problem number 10. It's different than the one we just did. Now what are these green and blue things you're given? So you can try it first and then just listen to me afterwards. This is your apothem. This is your radius. So are we given the perimeter? We can't find the perimeter because we don't know any of the side lengths. But we can find this piece right here using a right triangle, right? Because the apothem always forms a right angle with the side. So 10 is our radius, which is our hypotenuse, and 6 is one of the sides, and we're looking for that red side. All right? So a squared, b squared, c squared. We got 10, we got 6, and we're looking for our a, or our x. X squared plus 6 squared equals 10 squared. X squared plus 36 is 100. X squared is 64. X is 8. So that means that this is 8. Now, is that the entire side? No, that's how much of the side? Half the side. So if this piece of the side is 8, the whole side would be 8 times 2, which is 16. So if one side is 16, and this is a three-gon, or a triangle, it'd be the number of sides, which is 3 times 16, the perimeter is 48. All right, now what's my apothem? We already had it, that was 6. Use our formula, 1/2, apothem times perimeter, half of 6 times 48. Bam, there's our answer, 144. All right, see, I told you. It's a little more difficult, but not too terrible. Now you're given the side length is 10 here, and you're given the radius is 13. So find the apothem, use the apothem to find your answer. All right, ready? Right here. We need to use this thing. 13. First thing, half of 10 is 5. So that bottom piece is 5. 13 is our radius. That's 5, and that's A. That's our apothem. Okay? Even though this is probably going to be larger, but it doesn't matter. So half of 10. Half the side is 5, so this piece is 5. 13, and we're looking for A. 5 squared plus A squared is 13 squared. I can tell you right now, A is going to be 144. All right? And A is going to be 12 squared root of 144. All right, so even though this isn't drawn to scale, that's all I have to know. So we go next, and we're going to say, all right, that's my apothem, 5-sided figure, pentagon. 5 times 10 is my perimeter, which is 50. My apothem we found to be 12, not 6. Uh-oh. Let's hope I didn't mess this up. Oh, there we go. And your answer is 300. Wait a second. That's not your answer. let's see. That should say 50 too. So your answer is 300. So this should say 12. This should say 12 times 50. Half of 12 is 6. 6 times 50 is indeed 300. All right. Bunch of little typos in that problem. You can tell I just popped these together real quick to give you some extra problems. All right, so let's go with these. Missing the side length for number 12. This is going to be the last two. This is good practice. All right, because this brings back everything we've been doing. So let's go with this one. 13. So if this radius down here is 13, the one up here is also 13. So there's our right triangle, and we're looking for A, which is half our side length. So 13, 11, we're looking for x. Okay, that makes sense? So x squared plus 11 squared is 13 squared. 121 subtracted from 69 is 48. Square root of 48 is almost 7. Not quite, it's 6.9. Half of that is 6.9. So the whole thing would be 2 times 6.9, which is 13.8, right? 13.8 times 6, don't forget to multiply it by the number of sides. 82.8. Apothem here was 11. 1/2 of 11 times 82.8, and you get 455.4 as an answer. Good? Awesome. Last one. You need to find the apothem. So you're given 12 here. Half of 12 is 6. So you got 6, 10, which is my radius, 6, which is right there. All right. And we're looking for A, our apothem. A squared plus 6 squared is 10 squared. 36 subtracted from 100, once again, is 64. Square root of 64 is 8. All right? Perimeter, 12 times 5 is 60. Apothem is 8. Half of 8 times 60, 240. Yes. All right, so that concludes area of polygon. So it was a little difficult once we throw this stuff in, but as long as you know 1/2 apothem times perimeter, you know the perimeter is the distance around a figure, you know that the apothem is the distance from the central angle to the midpoint of a side, you are set to go, okay? There's really no more difficult area to find unless it isn't a regular figure. So if you could handle this, if you can handle problem 3, which I throw in there, which is a bunch of the stuff thrown together in a regular figure, you are set to go. So until the next time, we're good. All right? Awesome.